There are more than 4,400 bridges on Vermont's local roads. They come in all sizes and shapes, whether it's a short-span bridge in Stamford, or a long-span bridge in Huntington, a narrow covered bridge in Tunbridge, or a modern two-lane bridge in Williston. Vermonters depend on bridges every day to carry people and goods. Local bridges are essential to Vermont's transportation system. But Vermont local bridges aren't as young as they used to be. They are taking a beating. Like anything else made of wood or stone, steel or concrete, bridges wear out. In Vermont towns, about 2,000 bridges need upgrading or replacement, but we simply do not have the money to do the job. How did we get so many deficient bridges on our road system? Increasing volumes of traffic, more tourism, heavier loads, the freeze-thaw cycle of Vermont winters, heavy use of road salt, all contribute to the deterioration of roads and bridges. A major cause is the lack of regular maintenance. Failure to perform preventive maintenance on bridges allows slow deterioration to get the upper hand. In just a few years, a small problem can become a big problem. It takes a lot of money to build a bridge, from $2,000 to $4,000 a linear foot. It's a big investment of taxpayers' money. But any large investment is an investment worth preserving. Towns that perform regular, planned bridge maintenance can be sure that their bridges will be safe and dependable. They can also be sure that bridges will last many years. This videotape and the accompanying handbook show how Vermont local road crews can perform 8 bridge maintenance practices. Using common tools, any Vermont road crew can do the same. The 8 practices are: inspect town bridge, cut back or root out vegetation, remove debris, wash bridge, create smooth transitions, waterproof concrete surfaces, patch concrete decks, post bridges. By making these 8 practices a regular part of a town-wide bridge maintenance program, municipal road crews can prevent bridges from deteriorating rapidly, extend their useful life, and save money in the long run. Let's look at these practices now. Refer to the handbook for further information. Every 2 years, the Vermont Agency of Transportation inspects bridges which are 20 feet long or longer. While Vermont AOT reports provide useful information, they do not reflect all the bridges in the town, nor do they contain enough detailed information on maintenance needs to set up a municipal bridge maintenance program. Refer to the handbook for a sample bridge preventative maintenance checklist. It provides space to make comments not only about the bridge itself, the deck and the stringers and so on, but also about the abutments, piers, and trusses. The form also reminds you to inspect the approaches to a bridge and the waterway. Remember, look under the bridge as well as on top. You will never notice some critical bridge problems until you look underneath. Regular inspections will help you in many ways. First, it includes all town bridges. You can track bridge performance year to year. It provides a written record for all to see. It's also a good idea to take a few pictures and set up a file for each bridge. Pictures are good reminders of what you actually saw, and you can show the bridge to others without going back to the site. A second step is to cut back or root out vegetation. First, on the approaches to the bridge, especially on the banks near the abutments, cut back brush and small trees. In only a few years, a plant's root system can cause considerable damage. Cutting brush on the approaches to a bridge also creates better visibility for drivers. If you see small plants growing from cracks or crevices in the abutments and other members, pull them out. Small plants can grow into large bushes or even into small trees and force cracks even wider, eventually leading to the failure of an abutment. Be alert for signs of small animals. Muskrats and woodchucks sometimes burrow holes either into the approach banks or close to the abutments, letting water enter the fill. An excellent preventive maintenance practice is to remove debris such as trees, logs, and brush that is lodged in the channel, both upstream and downstream, or against the bridge. Do not leave it on riverbanks to be picked up by the next high water. Debris left in the stream often causes more debris to collect against it and to restrict the waterway. If it is not removed, debris can create new, faster currents which erode fill material from the stream bed and banks. This scouring action can also undermine piers or abutments. In some cases, it may be necessary to hire a crane or other large equipment. One of the most important and one of the easiest preventive maintenance practices is to wash down the bridge in the spring. A small portable high-pressure pump is a useful tool. If you can, arrange with the fire department to use their pumpers. Before washing, sweep the deck and pick up as much of the debris and sand as possible. This minimizes material getting into the stream below. Winter sand mixed with road salt attracts moisture. When water is left to pond on bridge decks and other members, the mixture causes rust and weakens concrete. Crews should remove accumulated dirt and salt before it does any damage. Wash the deck first with a stream of water, taking the highest areas first and then proceed to the other areas. Wash all dirt from the drain holes and expansion joints. Get under the bridge and wash dirt from the trusses, panel joints, and bridge seating, anywhere dirt and salt has collected. The transition from the road onto the bridge deck should be as smooth as possible to avoid vehicle loads from abruptly hitting the deck. Severe and repeated jolts by heavy loads can weaken the bridge prematurely. Bumps or holes in a paved approach may cause a sharp impact on the bridge. Repair these. On gravel roads, approaches tend to build up above the deck. This buildup often extends onto the deck, especially if the bridge is at the foot of a hill. Due to blading, dirt may carry out onto the bridge deck and, if left there, can accumulate in increasing depths. Cut down gravel approaches with the grader. Keep bridge decks reasonably free of dirt and gravel. You may have to do some handwork at the corners of the bridge where the blade cannot reach. On gravel approaches, laying down a bituminous asphalt surface about 25 feet at the approach to the bridge will help to solve the problem. Portland cement concrete is subject to spalling, the separation of surface concrete. An excellent preventive maintenance practice for protecting Portland cement concrete is to coat the surface with a 50-50 solution of double-boiled linseed oil and petroleum mineral spirits. The solution waterproofs the surface and retards the penetration of salts and chlorides, the culprits that cause spalling and scaling of concrete. Here are two ends of the same bridge, one end on which the solution was applied and the other end where it was not applied. See the difference this technique can make? Concrete surfaces should be cleaned and washed each year and oiled every 2 years. Application may be by spray or by hand brush, but should be uniform. Use the solution on new and on old concrete. However, it is most effective in preserving sound concrete surfaces. Usually, it is not applied to the underside and backside of a structure, which are less exposed to chlorides. Concrete decks are subject to wear from traffic, spalling due to de-icing chemicals and frost, and cracking of the concrete in the early age of the deck. Cracking allows moisture and chemicals to penetrate to the reinforcing steel, which then rusts, expands, and spalls the concrete. When cracks occur, seal them as soon as possible with approved sealers. If spalling is extensive, get the advice of an engineer. It may be more cost-effective to contract out the entire project as part of a bridge rehabilitation job. Use a slow-setting mortar when you can control traffic for a long period, say 3 to 7 days. Use a fast-setting mortar, which is more expensive, when you can restrict traffic for only a few hours. Remove all loose and deteriorated concrete down to sound concrete and blast the area clean with a dry blast. Coat reinforcing steel with epoxy bonding compound, unless using epoxy mortar. While epoxy is still tacky, place mortar in the patch area, screed and float the patch material even with the deck. Make sure to let the material cure well. Vermont municipalities have a responsibility to post bridges to warn drivers of the maximum load limits allowed on bridges. Posting of substandard bridges is a warning to protect public lives and property. Another goal of bridge posting is to reduce unnecessary wear and tear and prevent premature bridge failure. Overweight and overwidth farm machinery, gravel and cement trucks, logging trucks, and other vehicles damage structural bridge members. Repeated overloads can easily weaken already substandard bridges and even cause bridges to fail. If you have questions about the proper loads you should allow on a particular bridge, it's best to get professional advice. Weight limits should be based on professional engineering judgment. Once you determine load limits, post signs according to the manual on uniform traffic control devices. If engineers determine that the structure is safe for carrying state-designated loads, no posting is required. Make sure to send notices of bridge posting to appropriate users of the bridge and to appropriate school, police, fire departments, and other officials affected by posting. This concludes the videotape Bridge Maintenance for Local Road Crews. For more information on bridge maintenance practices, refer to the manual which accompanies this video, or call Vermont Local Roads. Remember, regular routine bridge maintenance can work for you. It will extend the life of town bridges, provide needed service to the traveling public, and save you money.